Hi students, this is AJ sir. Let's study 9th standard ICSE Math 4C and 4D.
In this exercise, we have a slew of formulae, but we need to remember just one important formula, which is a plus b plus c the whole squared is a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Then if we are careful about the signs, then we need not remember all these derived formulae. Let's look at the first sum. Now in question 1, let's cancel Roman number 1 and Roman number 3 because they are very easy and of the same type, so I want to reduce your homework. Let's do Roman number 4. We've got two brackets, so we could have used a formula, but I prefer distributive multiplication. That way we won't have to remember any formula. Please check here, the first terms are same but the second terms are not same, so that is why I'm not using any formula. X, that is the first term, multiplied by the whole bracket, minus 8, the second term, multiplied by the whole bracket. When we open the brackets, we have to be careful about the signs. So x into x is x squared, x into minus 10 is minus 10x, minus 8 into x is minus 8x, and minus 8 into minus 10 is plus 80, because negative into negative is always a positive number. Now the like terms together, minus 10x minus 8x is minus 18x. Since the signs are same, we should add the numbers and sign of the bigger number, which is minus. We can't simplify this further. I can't remove anything common. This is the final answer. Next, in 2.2, again we've got two brackets, so let's use distributive multiplication. First term of the first bracket multiplied by the second bracket plus the second term of the first bracket multiplied by the second bracket once again. 3a into 2a is 6a squared. 3a into minus 3 upon b. First multiply the numbers. 3 into minus 3 is minus 9. A remains a numerator and b is a denominator. Plus 2 upon b into 2a. 2 into 2 is 4. A upon b. Next 2b into minus 3b. 2 into 3 is 6. And in denominator we have b into b, b squared. And since there was a minus sign, that will stay as it is. Like terms together, here we have the same denominator, so no need to take any LCM. Just bring the numerators together. We get this as the final answer. Now in exercise 4C 3.4, this is of the format a plus b plus c the whole squared. Yes, there are some negative signs as well. We'll have to take care of that. Now the formula is, there is only one standard formula I want you to remember. A squared plus b squared plus c squared plus 2ab plus 2bc and plus 2ac. But let's talk about the negative signs here. In the first three terms, a squared plus b squared plus c squared, the negative sign doesn't matter. I could have written minus 3y the whole squared and minus 2 the whole squared, but that won't make a difference because minus 3y the whole squared will still give me 9y squared. The square gets rid of the negative sign. So the first three terms, you may simply write it as a squared plus b squared plus c squared, positive. If you write minus 2 the whole squared here, still you will get 4. But for the next three terms, the negative sign matters. Plus 2ab. So let me write this down here. A squared plus b squared plus c squared plus 2ab plus 2bc and plus 2ac. So here a's value is 5x, b's value is minus 3y, don't forget the negative sign here, plus 2bc, so b's value is minus 3y and c's value is minus 2, plus 2ac. So again a's value is 5x and c's value is minus 2. So a squared, b squared, c squared, open the brackets, 2 into 5, 10, 10 into 3 is 30, minus sign is there, so minus 30xy. xy. Next, minus into minus becomes plus, so this term will be a positive term. 2 into 3 into 2 is 12 and only variable is y, so let's write y. Here I've got one negative sign here, so this term will be negative. 2 into 5 into 2 is 20 and the only variable is x. Like terms together, no. Anything common can be cut, added, subtracted, nothing can be done. This is the final answer. Now in Roman number 5, again it's of the format a plus b plus c the whole squared. So let's use the formula. We've got a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ac. Now again in the first three terms we don't have to worry about the signs because there is a square involved. So these are the first three terms. But here we'll have to be careful about the signs. X and x got cut, so what is left is minus 2. Here also minus 10 upon x and here plus 10x. Any like terms together, I can only see 25 minus 2, which can be solved further. That's 23. That's the final answer. Now in the fifth sum, they've given us two values and they've asked us to find a plus b plus c. In such sums, we should always start with the formula, which is a plus b plus c the whole squared is equal to a squared plus b squared plus c squared plus 2. We have taken common here to get this bracket because this bracket's value is given in the question. So we substitute that value as well as the value of a square plus b square plus c square, which is also given. We get 81. Now the square goes on the left hand side to become square root, so we get the value of a plus b plus c as plus or minus 9. Now in the eighth sum again, two values are given and the value of this is asked. So we'll directly jump to the formula here. X plus y minus z the whole squared, because the value of this is given. So take care of the minus sign. And the formula will be x square plus y square plus z square. As you know, for the first three terms, the sign doesn't matter. But what should we write inside the brackets here? Well, we need not worry about the signs. Just copy this expression from the question. In the question, they have already given the expression. So just copy it. Don't have to worry about the signs. We can substitute the value of this and of this. The only thing missing is the value of the brackets. So we solve further and we get the final answer. Now in exercise 4D, there is no new formula we need to learn. In the first sum, this is given as 0, x plus 2y plus 3z, and also x cube plus 4y cube plus 9z cube is given as 18xy, and we have to evaluate this. That is, we have to find the answer of this. By the way, in exercise 4C, you have to mark the 8th sum as IMP. Now let's see how to solve this first sum. We start with this information, x plus 2y plus 3z is equal to 0. Now if you look at the question given, we have x plus 2y, which is the first two terms. Then we have 2y plus 3z, which is second and the third term. And then we have 3z plus x, which is the first and the third term. So what we'll do is, we'll get the respective values of these three numerators in the given question by shifting the third term on the right hand side. So x plus 2y is minus 3z, 2y plus 3z, shift minus x, and x plus 3z, shift, and this becomes minus 2y. So now that we know these three terms, let's substitute those values in the given question. And by squaring, we reach this stage. Now these are three fractions and the denominators are not the same. So let's equalize the denominators. Let's put here a z and into z. Here I need an x, so into x. Here I need a y, so into y. So this becomes 9z cube. This is x cube and this is 4y cube. And the denominator, the common denominator is x, y, z. Now if you note, the numerator the numerator's value is given in the question as 18xyz. So now we can substitute that value here. xyz gets cancelled, and the final answer is 18. Now in question 3, we will have to expand this entirely, and then we will be able to find the respective coefficients and the constant terms. So let's begin. So we've got two brackets, but we cannot do distributive multiplication. There is a power of 2. So first we'll have to use the formula and expand this bracket. A minus b the whole square is a square plus b square minus 2ab. Now we can do distributive multiplication. That is the first term multiplied by the whole bracket minus 8 multiplied by the whole bracket. So again we will do distributive multiplication. 2x square into x square is 2x raised to 4. And then this 2x square into 16 is plus 32x square. 2x square into minus 8 is minus 16x cube. Next, minus 8 into x square is minus 8x square. Minus 8 into 16 is minus 128. And minus 8 into minus 8x is plus 64x. Now the like terms together, that is 32x squared minus 8x squared is plus 24x squared, and also I've arranged it in the decreasing order of the powers. And now we can answer the questions. Roman number 1 is, what is the coefficient of x cube? That's minus 16. Next, what is the coefficient of x square, which is 24? And what is the constant term? That is minus 128. In the fifth sum, they've given one equation and they've asked us to find these two values. So first of all, using the equation given, we shall find the value of x plus 1 upon x. So first send 2 down, and then like we have done in the past, divide the entire equation by x. So x and x gets cancelled and x and x gets cancelled. We get the value of x plus 1 upon x is equal to 5 upon 2, and then finding the required values is so easy. To find x minus 1 upon x, we shall use this formula. There are some other methods as well, but I prefer this formula. Here x plus 1 upon x value is known to us, we just found it, and x minus 1 upon x value is to be found. Substitute the values. Minus 4 goes to the left and this goes to the right. Remove LCM. Square goes to the left and becomes square root, and don't forget to put the plus and minus sign here. Also, they should be converted to a mixed fraction, which would be 1 upon 2, plus and minus. And now the Roman number 2, we have to find the value of x cube minus 1 upon x cube. So there is a direct formula for that. Here we know the value of the brackets, we just found it in Roman number 1. So substitute that value. Of course, no need to mention the plus and minus sign. We can introduce that in the end. Find the cube, remove the LCM, and get the answer. Now in question 6.2, again, two values are given, and this is what is asked. Now to find 6.2, we'll have to find the value of a minus b and a plus b the whole squared respectively, using the values given. So we'll start with that. First, we'll find the value of a minus b the whole squared using the usual formula, because we know the formula of a square plus b square as well as ab from the question. Also, we'll find the value of a plus b the whole squared using the usual formula. Then we can start the sum. This is the expression given in the question. Substitute the two values which we just found, the two brackets, and get the answer as minus 46. Now when you will solve Roman number 1 for homework, you may use these values directly, no need to calculate them once again. Now the eighth sum is IMP. They've given the value of x squared plus 1 upon x square, and they've asked to find the value of this. Now here, if we start with the given expression and we rearrange the terms, and here we remove 7 common and 8 common. So we see that we just need the values of these two brackets, x cube minus 1 upon x cube and x minus 1 upon x. So that's the hint about the direction we have to take in this sum. So let's find these two brackets value first. So this is what is given in the question. We shall manipulate a bit with this expression, this equation, subtracting 2 on both the sides. The reason we are doing this is because now this becomes a formula. This is a square plus b square minus 2ab. By the way, a and b were actually x and 1 upon x, which got cancelled, so they disappeared. But this becomes x minus 1 upon x the whole squared, and if you remember, this was one of the brackets we required. So sending square on the other side, it becomes square root. And now let's find the other bracket. This is the other bracket that we have to find out. So we use the formula here and we substitute the values root 5 and root 5 respectively. No need to put the plus and minus sign everywhere, because after solving we'll introduce it once again in the end. Now root 5 into root 5 into root 5 is 5 root 5, and 5 root 5 plus 3 root 5 is 8 root 5. So now that we've got the values of both the brackets, let's substitute the values here and we'll just add them up. And don't forget to introduce plus and minus sign in the final answer. Now in the 10th sum, this equation is given and we have to find x cube plus 1 upon x cube. So starting with this equation, we will cross multiply first, then we shall shift minus x square on the other side, and we have done such sums. We divide the whole equation by x, so that x and x gets cut, 1x gets cut in the numerator, and we are left with this, x plus 1 upon x is equal to 5. Using this, we can find what is asked. X cube plus 1 upon x cube formula is this. We know the value of the brackets, we just found it out. Substitute that, calculate, and get the answer. Now in the 12th sum, the sum of two numbers is 7 and the sum of their cubes is 133. Find the sum of their squares. So here, let's write down the data. Let the two numbers be x and y. So x plus y is equal to 7. Sum of the cubes is given and sum of the squares is asked. So we'll use two formulae here, the cube formula as well as the square formula. First, starting with the cube formula. X plus y is equal to 7, cubing both the sides. Use the formula, expand it. The value of x cube plus y cube is given, and the value of x plus y is also given. So we can solve this and get the value of xy, which is what we wanted to solve the next part, because in the next part, in the square formula of x plus y the whole squared, we have x square plus y square plus 2xy. Now x plus y value we know, x square plus y square value we have to find out, and xy value we just calculated it to be 10. So solve further and get the required answer. Now in 13.3, this is the equation given and we have to find the value of a. We'll be comparing the LHS and RHS to get the answer. 13.1 is cancelled because it is easy and of the same type. Now I can clearly see that if I open this bracket using the square formula, I will get 9x square and 25. So they might get cancelled. Let's solve it and check it. Yes, indeed, when we solve the RHS further, we get we use the formula of a squared plus 2ab plus b squared, so that 9x squared and 9x squared get cancelled, 25 gets cancelled, so only the middle term are left behind. And even there, x gets cancelled, so we solve further and get the value of a. Now in the 14th sum, this equation is given and these two expressions are to be found out. So the first thing we'll do here is convert the mixed fraction into an improper fraction, and here you can separate the denominators, because by doing this x and x got cancelled, so we get x plus 1 upon x is equal to 10 upon 3, and then it becomes very easy to find what is asked, which we've done so many times in the previous sums. To find x minus 1 upon x, I prefer to use this equation, although there are some other methods as well. Here substitute the value as 10 upon 3, then shift this on the right hand side, minus becomes plus, 4 becomes minus 4 when shifted to the LHS. Remove LCM and bring the numerators together to reach this step. Square goes to the other side to become square root, and don't forget to put plus and minus sign in the answer and to convert it into a mixed fraction. So we got the value of x minus 1 upon x, which we can use in our next part. In Roman number 2, they have asked us to find the value of x cube minus 1 upon x cube. So we use the usual formula and we substitute the value. It would have been better if I would have substituted 8 upon 3 here, and because cubing becomes straightforward, and 3 and 3 gets cancelled here, remove LCM, solve further, and of course convert it into mixed fraction, as well as put the plus and minus sign.